Hello everybody, welcome back to From Rhythm to Algorithm, part 58, Codomain and Range. We're going to ask a simple question, we're not going to answer it, we're going to have proof, and we're just going to keep exploring a lot of different stuff we've been talking about. I have algo, something, in Spanish and Espanol, and highlighted, because again I'm working out that proof of literally the entire Spanish language. So that's a real subtle one, and again not too important. And this proof just goes out to get all of the CEOs that make over, if you get paid more than $1 million a year and you're stealing my property, this really goes out to you guys. You guys can't think, can't educate your own children. So we're going to keep trying to discuss, again, base and range. We've talked about, and again, as subjects of lecture series, I've used the word integration, and I've talked a lot about iteration. So, again, a lot of mathematical concepts to talk about, but pretty much just structured mathematics today. Like I said, or I guess I haven't said yet. Go ask any mathematician what's the difference between a codomain and a range, and I guarantee you whatever fucking words come out of their mouth is not the correct answer. So let's start there. I'll just Google it. I did Google it before this, but again, most of the vast majority of all. I'm just got an email interviewed for my business from some fucking fake ass people who can't even speak any English at all. But what I was saying was most of my derivations literally come from me sitting outside and writing down my thoughts that come into my head without like literally any, at least when I'm doing English, any dictionary definitions. When I look stuff up, it's just to see what you people are saying about it. Let's see, it's a codomain versus range. And like it comes up as like people also ask, right? When we're talking about consolidating information, when people also ask our suggestions on Google, this is because people have asked this question in their brain and they ask another person what's the answer and they don't get a convincing definition response, right? Associations of words. The codomain is the set of all possible values which can come out as a result, but the range is the set of values which actually comes out. Okay. Again, remember, we're looking for physical motivations for these words. Well, what the fuck does that mean? Right? And again, specific to mathematical researchers, they're happy to jerk off with symbols and stuff. Look around the room, what the fuck, what is that supposed to mean? Again, it says, explicitly it says the difference between codomain and range. Codomain, it refers to the definition of a function. Range, it refers to the image of a function. And that's all I'm going to say from whatever that tells me literally fucking nothing. Again, from physical motivations, and then from that you guys fuck up the logic and the mathematics. But so that's the question we're going to be exploring. And so now we're going to start with a proof. And so I said I'm not going to answer it, but I'm telling you that is not the convincing mathematical differentiation. That's not a clear difference to me. Function, image of functions. Image would be like mirror, mira, look, see, reflect, but that's all I want to talk about for their logical assertions of what those words mean. But now we're going to start with a proof, and then we're just going to talk about a bunch of different things. I have a bunch of theorems written down, and I'll just be responding to them with whatever comes to mind. Historical proof. What's the opposite of integration? Right, in math class, it's clearly derivation. Right, our fundamental theorem of calculus, if you integrate the derivative of a function, you get the freaking function. So the opposite of integration is derivation, right? That school is integrated. That school is segregated. So consolidation from historical levels of logic, we've opposed integration with segregation. And remember, we're trying to find the base and range of the most applicable definitions with a bunch of different forms of the words that represent different logical contexts. So that's the whole proof. There's an integrated school has white and black children. A segregated school has segregation, division. So now I just have logic and language versus the physical world versus math class. And now again, the first things I'm going to respond to again are just mathematical words or operations, and try to say other words that imply the same logic. Right? Segregation, division. Right? A segregated school has divided students. Yes. Integration, addition. If I integrate, and again, that's segregation to division, very convincing, very clear, no question. Integration adds, to contribute, to put forth, addition. Derivation is reduction to me, right? I've said that I drove it is what it is while knowing a lot more words. Not pretty logically convincing, but not one-to-one logically for me. Iteration, I have to multiplication with a question mark. If I think iteration, the next words out of my brain are to do something again with the goal, with a physical motivation of efficiency, to improve, be it closer to the best you can be. And then I say multiplication, multiply, more, multiple. So iteration to multiplication, right? So these are the top words are the ones I started with, and then the bottom ones are the words that I try to come up with. So iteration or multiplication is the only thing I could come up with for iteration, but they don't even strike me as similar logically or mathematically. Iteration, to do again. Again, I can't think of another shun type word, another close to a mathematical operator type word. But multiplication, to do again. Right, in math class we have division against multiplication. So, again, what's a more convincing physical reason as to why we use which words? Now I just have up here, again, a set, x, operation, time, and then f of x, your output. Input, output. An operation takes some amount of time, right? Addition, subtraction, multiplication, whatever. Physically, if I wanted to add Burger King to my diet or to my day, I would literally have to go get Burger King or have to go do something after get it delivered. So any operation in the context of math is taking time. Again, a function. Functions contain operations. And now let me make sure I'm still rolling, and I'm just going to read through the theorems I have and just respond and talk about what I think about it. So now the first one I have, right, if we want to break down the word codomain, right, range is pretty apparent to me physically what people mean. If I said my range of my vocality, the amount I can sing, very directly physically. I can go outside, stand on my porch, and the range is the person that can't hear me anymore. That's where the range is at. We could even define that down to literally the quantum level. Shout out Prof. Carol, quantum mechanics, ever ready you. Oh God. Why am I on part 58 with no fucking money still doing this fucking level of derivation is beyond me. Oh well, let's keep going. But if we want to break down codomain, we can just break down, right, I said range is clear logically to me. Codomain in structured mathematics with 3.9 GPA in graduate classes. Then I go to normal conversation and say, be straight with me, Bill, what the fuck is codomain? Logically, physically, out in the world, I don't know. But how about domain? What's a domain? The first word that comes out of my mind is territory. An animal marks his territory. That's his domain. C, yes. So domain is range. Territory is domain. Output is range. Input is base. Domain versus codomain. Now we have some sort of biological, evolutionary type of definition, one-to-one for domain. So codomain, like that strikes me, that linguistic form strikes me as like co-inhabitants. Habitants, co-inhabitants. Like an unnatural, not even preposition, but just an unnatural prefix. So I think that's logically what's going on. And then we have a physical proof. Bass is bass. Ask any musician. Like the physical bass, B-A-S-S, is the bass of vibration of a song. So we can have bass, like the instrument is bass. We can call that the fundamental theorem of vibration or of music. And then I have physics question mark. Because I would say like mass is the base of physics, or again vibration, but then a lot more physical derivation to go in there. But just bass is bass. The bass instrument is the lowest frequency tone. Base to range is function. Base to range is function. Our base, our operation plus time, gives us our output, our f of x's, our y's. So base to range is function. Base plus operation time produces function. Base plus an algorithm produces function. Base is input, range is output, function is operation. Right? So functions contain operations, now we're saying function is operation. We said, what is iteration to derivation? Right? Again, from our direct historical logical proof, what's the exact difference? Right, we've talked about iteration versus multiplication, but this makes me say, right, you say division, multiplication, iteration to derivation, right? Iteration to do again, derivation to reduce, deduce, reductive, base is derived from range, already talked about that. And then I have, again, to return to physical motivations. How do we impose the 100% limit of motion to range, codomain, and derivation? Right? I can't force equals mass times acceleration. I can't move anything with mass without it giving enough force, right? You go into space, you float around. So, right, if I squat down in a tense position, there's a range, there's a limit to how high I can jump up. So how do we apply, again, based on the mass stored in the action potential stored in my muscles? So how do we apply that to, again, all of these conversations of structured mathematical things? How about the relationship of tangents and derivatives, right? In physics, tangents are very clear. It's the anything in circular motion, which, by the way, is everything. Everything is always in circular motion because of orbits. But the tangent is the perpendicular vector away from the centripetal or centrifugal, whatever the fucking correct one is. But what's the relationship of tangent and derivatives? Derivatives imply less, right? You have something, we have our 100% limit. Derivative implies less, right? You take any function, you take its derivative, you're going to go to, no matter how many derivatives you have to take, you're going to get to zero at some point. So derivative is lessening. Tangent does not imply anything physically to size to me. Linguistically, right? If we're in a conversation, we go on a tangent. Those are logical tangents. Those make you think of other things. Other words pop into your brain. So very clear tangent physically and logically, linguistically to me. And again, I just have what's the relationship with derivatives. Don't know if there is one. Me thinking through my logic. And I have base is minimum, range is maximum, generality is range. Now getting back to really structured linguistics, right? The more it is what it is applies to everything. Every logical anything. You can say that in every context and it makes sense. People will be like, yeah, inspiring. But generality is range. The more applicable it is general. And then we have, right, domain is range because our definition of domain is territory, right? The alpha male has more territory. That's his domain. So that definition is logically consistent. Very clear there. But then this is where the logic and the definitions don't make sense to me. Because what's the opposite of generality? Specificity, right? Specificity is base. If you're in a natural conversation with somebody and someone says, and you say something and the person responds, basically, what logically did they just tell you? Well, that's about right. That's generally correct. So we use the natural term basically as general. But this is what I do. This is me actually showing you my derivations, and then I will click pause on this video, and I will just keep doing this all day. But I just have basically used naturally means almost, right? It's about correct. It's generally correct. But what definition in all of known human history of physicals, math, science, all that history shit am I missing to say here's what sensorality is and here's how we pair it to a mathematical operator? I don't know. Again, go ask a mathematician what's the difference between codomain and range, and I guarantee you they're going to give you a much less convincing answer than this discussion right here. So thank you for watching From Rhythm to Algorithm, Part 58.